Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled The Path Planning Scheme Using Decision Model and YSGA for Joint Charging and Data Collection in WRSNs. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today we are here to present one of the research area that is basically related to wireless rechargeable sensor nodes. So this is basically for the path planning of the wireless nodes. So before talking about this topic and the work done, let's talk about what we will cover in this video. In this video, we will discuss about the application areas in which this application, the designed code can be used. Along with that, we will discuss about that whatever the code we have designed, how to execute it, what are the software requirements for it. Along with that, what are the current systems and the problems in that, and what we have done in the proposed work will also be given in the brief in this video. Finally, whatever the experimental outcomes and the findings will be there, we will give an overview to that also. So initially, let's talk about the application areas. As currently, wireless sensor networks can be used in number of the application areas like habitat monitoring, disaster, agriculture domain, healthcare domain, for the military application, for the network management, and many other applications. If you go in the brief, you can see the different application areas like monitoring, at the remote locations where easily the human cannot survive. There the sensors can be deployed for the military operations, intelligent transportation services, and many other applications. So recently, as this is not a new domain, but in the future, in order to improve their capability, the concept of mobile wireless charging is introduced, in which all the sensor nodes, those are deployed at the remote locations, those are made capable to be get recharged by the mobile charger, which get charged from a particular location. So how to route that mobile charger, because that is also restricted to some constraint of the energy and the power with them. So it is mandatory to get the path of that particular charger. So inspired from this, in order to support the future of the wireless sensor networks, we are deploying this method. So let's initially see that what exactly the code is and how we need to run it. So you will get a folder named code, under which there are two of the folders. One is with the proposed one and another one as a base paper. So you just need to open one of the folder. Along with that, you need the MATLAB software. So you can use 2018 or the upper version. Here I am using MATLAB R 2019. Make sure it should be a full version. So you just need to copy the path of the folder in which your code is placed and go to here and control V paste. Press enter. The all files will be shown here in the current folder. As you can see, here are a number of files and the functions which are implemented by us. So this is the base paper in which this is a base paper code in which we have implemented the ACO code, because the base paper that we are following is basically this. You can see it is an elsewhere model in which multi-objective optimization method is used. So they have used the multi-objective ant colony optimization for the mobile WCE routing. So what they have done, they have calculated a path for the route for the wireless charger node, and then on that they have calculated the results by changing the different parameters and the number of initial population in the terms of average value of number of Pareto optimal solutions, right? So what we have done, we have initially implemented this base paper in order to understand that what they have done. So all the scenarios and the parameters are taken by the base paper, in which the Emax, Emean, these are the different energies in joules and kilojoules along with the velocity. All the factors are initialized. Then the aunt colony optimization is implemented in order to get the root of the mobile charging node. So when we are running this, you just need to select this file and then you have to go to the run. It will execute the commands and it will ask you that how many number of aunts are there to find the optimal route. As you can see in the final stage, they have evaluated the result by changing the number of aunts also. Here 10 aunt, here you can see 10, 15, 20, 25. So all these scenarios are there. So you can just enter the value here. For example, let's say I am entering the value for the it can be anything because we have created it for the generalized. I am entering 5. When I press enter 5, the 5 aunts will be there and they will find a solution and will give you the results in terms of different parameters. The parameters that we have considered for it are the Pareto solution. So this is finding the solution by using the ACO, and we'll get the optimum results as per the iterations we have given. So the iterations those we have used for it is basically taken from the base paper so that we can compare it. So this is the Pareto solution at 5, at art is equal to 5, and this is the ACO root. As the count of the paths is very less, so that's why the it is not that clear. So we have the overall comparison in which we have run for the 10, 15, 25 and 20, and then finally compare the factors as per the base paper. So here you can see we have got the results by different aunt values. Along with that, we have the scenario in which the row factor and Q node factor of the ACO is changed. These are the two different code files we have generated for the ACO, Q factor and row factor changing. And finally, in the compare file, we have compared the results in order to show the graphs of the average Pareto solution by changing the row. We have considered at 0, 0 0.1, 0 0.2, 0 0.3 and so on by changing the row. Whatever the Pareto value is there, we have shown it here. So this was the ACO base paper with the multi-objective, right? So we have proposed the new algorithm that is based on the YSGA along with the fuzzy logics. So the main contribution of our research paper is, like, you just need to copy the path in order to run that. Then you just need to paste the path here. The folder will be changed. Here the main code proposed is there and the compare code is there. In the main code, what we have done initially, we have generated the fuzzy system. So what we have done, we have checked that route is optimum or not by using the fuzzy logics, and the best route selection is done by using the yellow saddle goldfish algorithm. So yellow saddle goldfish algorithm is an optimization algorithm which is used for solving meta-heuristic solve different SI problems. So it is a meta-heuristic optimization which is inspired from nature. So along with that, we have used the fuzzy logics in order to check that whether whatever the decision we are taking, whether for the root next hope, so it is taking the decision on the fuzzy logics. In the fuzzy logics, we have considered different parameters. So the initial stage is to define the fuzzy, in which ECH, e-transmission, distance, based inputs, and it is giving the weightage between 0 to 1, and the node with the higher weightage is selected as a next route selection. So the rules are given. Then we have designed the YSGA model in which the route is selected by changing the initial solution, changing the route, and evaluating the fitness function. In the fitness function, the route whatever is selected, their different parameters as ETRV, ECH, sending data, distance, all these factors are calculated. These factors are then passed to the fuzzy logics, where this fuzzy system which was generated in the initial stage, here you can see the a fuzzy is saved to the fuzz one. So in this, it is evaluating and getting the rating between 0 to 1, and along with that we have also calculated, because it is a multi-objective one, so we have calculated the PHI value, where E communication, ETR, EHV, which was the base paper fitness equation, was there. So on the weightage based with the fuzzy as well as for the base papers equation, by changing the weightage you can get the different results. So we have used 0.8 and 0.2% to the different weightages, and on that we have best route is selected. So this is also run for 10, 15, 20, and 25 scenarios, along with the, so that we can compare it with the standard ACO which we have already implemented in the base section. When I run on the compare, it will give you the results of the proposed one, as well as it will give you the results of the traditional ACO. Here you can see the curve. The average results for the proposed at population value of 10 is better in comparison to the ACO. Same for the 15, for 20, this, and this is the overall results for the YSGA fuzzy system. Finally, we have also compared in terms of the traveling energy consumption, that how much it is consuming during the traveling, and this is the energy when it is charging. So you can see in the proposed scenario, for all the aunt and the population scenarios, our proposed methodology, which is using the fuzzy based YSGA model for selecting the route, it is consuming less energy. So obviously, if less energy will be there, more the system will be more effective. So this is the work that we have done. So I hope you people like this video. Further modifications are still possible, because there is a scope of improvement in every of the research. To get those details, stay connected to us. We have also shown the results in the tabular form in order to support the results. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.